Evaluate the integral of 2x squared times the sine of x cubed plus 1 dx. Very complicated. Do it with a u substitution using u equals x cubed plus 1. Isn't that sweet? They told us what u should be. They saved us a lot of work by doing that, so it's easy to answer this question. Step 1, choose u. We already chose u. It was given to us. Let u equal the argument of the trigonometric function they gave us. That's what we're actually doing here. So u is equal to x cubed plus 1. Step 2, calculate the differential du with the definition u prime dx. Then du is the derivative of x cubed plus 1, because that's u, times dx. So du is 3 times x to the second power plus 0 dx. Step 4, rewrite the given integral of f of x dx as the integral of f of u du. After we do that, we can just go ahead and apply the fundamental theorem of calculus, part 2. The integral of f of u du is capital F of u plus c, where capital F is the antiderivative of little f. Okay, the original question was the integral of 2x squared times sine of x cubed plus 1 dx. I'm going to rearrange things to get it in the proper form of integral f of u du. That's the integral of sine x cubed plus 1 times 2 times x squared times dx. See, the stuff at the end is a little problematic. We want du to be at the end, but du is equal to 3x squared dx. So the first thing I'm going to do is pull that troublesome factor of 2 in front of the x squared. I'm going to move that outside of the integral. It's a constant. It can come outside of the integral. So we get 2 times the integral of sine of x squared plus 1 times x squared dx. Now a little more is needed to make that last part du. I'm going to introduce a factor of 1/3 on the outside of the integral to balance the introduction of a factor of 3 towards the end of the problem. See, I'm trying to get du, which is 3x squared dx. So 2 times the 1/3 introduction of the integral of sine times 3 introduced times x squared dx. Okay, so I multiplied by 3 and 1/3, so I did nothing. I multiplied by 1, and yes, I have my du fixed at the back. So this is the integral of 2/3 times the integral of sine u du. All ready to go, sine u du. Ready to apply the fundamental theorem here in terms of u. I get 2/3 times the antiderivative of sine. Well, cosine would give me negative sine, but I want sine, so it's a negative cosine of u plus the constant of integration. Okay, now I just have to replace u with what we said it was equal to. We were given that it was equal to x cubed plus 1. And then we'll name the constant c. Well, what do you mean name the constant c? Well, if we distribute multiplication by 2/3, we get negative 2/3 cosine of u, which is actually x cubed plus 1, minus 2/3 plus 2/3 times c. But I'm just going to call that c because 2/3 c, constant, and constant c, basically it's the same thing. A constant's a constant. It's not that important. If we took the derivative, we would get 0 of it anyway. So you can call it whatever you please. You can keep calling that c.